we're not going to be talking about the transformations with quadratics today. Section 2.2 talks about characteristics of quadratics. Now, the characteristics that we are going to be looking into are key characteristics that you really talk about with a lot of different graphs. But how you find these different characteristics is going to vary a little bit depending upon the format of the equation. Today, we're focusing in on characteristics when it's in vertex form, because that's the form we've been working with. That's the transformation format of our quadratics. What is vertex form of a quadratic function? Hint, it starts with f of x equals. And it's got a bunch of letters, like A's and H's and K's. We've written it down multiple times in the last 2 days. Go for it, Fred. There's no b in actual vertex form, so it's just x minus h. What goes here? Squared. Plus k. A parentheses x minus h quantity squared plus k. So, today we're talking about key characteristics when it comes to the graph of this function. Things that you should be able to easily find given vertex form. Now, it's called vertex form for a reason. It's called vertex form because you should be able to easily find the vertex, which is one of the key characteristics. Now, actually, before I put those semicolons, I'm going to change that to a parentheses. What actually is the vertex of a quadratic equation? Not how do we find it, but what is it when you look at the graph? Kind of. It's the bottom of the curve if it opens upwards. Otherwise, if it got flipped over, it's the top. It's the highest or lowest point in a quadratic equation. The vertex is that middle point that hits the maximum or the minimum. And yes, it is at HK. Reminding ourselves that because of the minus in the vertex format, what's that mean I got to do with H? Got to do its opposite, not flip. It's the opposite of the equation in the number in the equation. If it's a minus 3, it's positive 3. If it's a plus 12, it's negative 12. Another key characteristic that we're going to talk about is the axis of symmetry. An axis of symmetry is a line of symmetry. Within the graph. Now, our line of symmetry for a parabola, because that's another key characteristic of quadratic functions, is that their graphs are parabolas. But this line of symmetry of these parabolas will always go through the vertex. And that is a very important thing. By the way, you're going to generally see me call axis of symmetry AOS. I make the O small because of isn't typically a capitalized letter or word. Because of the fact that the axis of symmetry always goes through the vertex, what ends up happening, if I look at a parabola, let's say I draw a parabola here, let's say the vertex right there is at the coordinate point 3, 4. My axis of symmetry will be right here. Vertical lines. Are those x equal a number or y equal a number? No. Y equals a number is horizontal. That's a constant function. Vertical lines are always x equal to a number. Specifically, in this case, x is going to be equal to 3. Because the vertex has an x value of 3. And the vertical line should always have the same x values. That's why it's x equals. As on a graph, vertical lines don't move left or right, which means the amount they moved left or right to get to that vertical line, in other words, the x value that you went, because x is left and right, should always be the same. The x should always be the same. The axis of symmetry will always go through the x value of the vertex, which means the formula for an axis of symmetry is x equal to h when it's in vertex form. Another key thing that we talk about when it comes to quadratics or graphs in general is the y-intercept. The y-intercept is something that has a consistent way of how you find it, regardless of what form the equation's in, regardless on if the equation is quadratic. Because by definition, a y-intercept, if this is my x and y axis, a y-intercept is the coordinate point of where you hit the y-axis with that graph. And every single coordinate point along the y-axis has something in common. If you're hitting the y-axis, you didn't have to move either left or right to get to that coordinate point. Left and right is what variable in a coordinate point? The x. And if you don't have to move to get to your x, what is the x value of every single coordinate point on the y-axis? 0. Every single one of these is 0 something. We don't know the something because there's nothing actually marked on this graph. But every single one of them starts with 0, which means the y-intercept happens where x is 0. Now, since it is a coordinate point, it is the coordinate point 0, comma. If you know x is 0, how can you find the y value? Given an equation. You have an equation. You know x has to be 0. You'll plug it in. If you're given an equation, you're going to have x and y are the only variables. If you know x, to find y, you plug 0 in. So the y-intercept is at 0, f of 0. And if function notation messes with you, that just means to plug 0 in for x. We will also focus on if the graph is going to open upwards or open downwards. Now, we've already established what makes a graph open up versus what makes it open down. What does the parent function of a quadratic do? Does it open upwards or downwards? It opens upwards. What causes it to flip over? A negative where? A. If A is greater than 0, in other words, A is positive, it will open up. And if it opens up, that graph will have a minimum. If A is negative, in other words, smaller than 0, it will open down. And when it opens down, it will have a maximum. Because that's going to be another key characteristic, is asking, does it have a maximum value or does it have a minimum value? That goes hand in hand with the direction that the graph opens. The last two key characteristics are characteristics that we talk about a lot with various graphs. Domain and range. Domain and range have to do with your input or your output values. Is domain inputs or outputs? Inputs. Now, the only thing that limits a domain for a function is things that you're not allowed to do in mathematics. Things like you can't take the square root of what kind of numbers? Negatives. You can't square root negatives. At least not with staying to real numbers. And y'all will talk about imaginary numbers in advanced algebra B. Actually, no, I think we talk about it this term. Anyway. Can't square root negatives. You cannot divide by 0. This is what a quadratic function looks like in Vertex 4. Were there any square roots to worry about? No. Are we dividing anywhere in that? No. There's nothing limiting what you can put into a function's domain. Which means if there's nothing limited, what things can you plug in? All real numbers. The traditional way to say this is to say that x exists within the reals. The symbolism for that is the variable is x. This funky looking E thing, it's kind of like a C with a line through the middle. That means exists within. Real numbers is the double bar R. It's the R where you put a secondary line on the vertical piece. You don't have to write it this way. This is the way I will write it. You want to write all real numbers, that's fine. ARN means nothing. ARN has absolutely no meaning. Another option of how you can write it is if you prefer to just write the double bar R, that works as well. I don't know why I put parentheses around this piece other than to indicate another way of writing it, but in hindsight, I like the commas better. So those parentheses don't actually mean anything here. If you want to leave them, it's fine. You just want to write the double bar R for domain, that also works. That's a shorthand. Range is not all real numbers for quadratics. Range is your output values. All real numbers as a range indicates that the graph goes all the way up, goes all the way down, and hits everything in the middle. Parabolas don't do that. Parabolas either will go all the way up or they will go all the way down. They will not do both. If your graph is opening upwards, your y values will go upwards, which means if it opens up, the range will be y is greater than or equal to its lowest point. What's the lowest point? The vertex. Specifically, since it's y's, it's the y value of the vertex. If the graph opens down, the y's will be less than or equal to its highest point. And its highest point is still the vertex. And it's still y values. So, these are our graph's key characteristics. Today you're going to be asked to label all the key characteristics of the following function. As we've been doing quite a bit, you'll also be asked to sketch the graph. F of x is equal to negative quantity x plus 2 squared minus 3. Key characteristics include vertex, axis of symmetry, y-intercept, direction of opening, including if it has a maximum or a minimum, domain and range. They're going to be in vertex form. The vertex on this one is, well, vertex is always HK. In this case, HK is opposite of this, negative 2, same as this, negative 3. Axis of symmetry, x equal to h. In other words, x equal to the x value of the vertex. Negative 2. Y-intercept. Always going to start with a 0, because the y-intercept has an x value of 0. To find the y value, you plug it back into the equation. My calculator can do all of that, or you can follow PEMDAS. If you're going to do PEMDAS, what should you do first? Parentheses, what's 0 plus 2? 2. What comes next? The exponent. That'll become a 2, technically squared. What's 2 squared? 4. Then the negative is in front of that. I get negative 4 minus 3, which is negative 7. My y-intercept is at 0, negative 7. Direction of opening. Does this one open up or open down? See that negative way in front? What's it mean happened to the graph? Was like this, it flipped. Did it open up or down? Down. And if it opens down, then does it have a maximum or a minimum? Maximum. Now, You don't have to point this piece out. You have to tell me it's a maximum. In all technicality, the maximum is at the y value of the vertex. I'm okay if you just write max. But that is specifically where the max is. Domain and range. Domain's really easy. It's always the same thing for quadratics. All real numbers. Again, you'll see me write the fancy version. If you just prefer the double bar R, that's fine. If you want to write the words all real numbers, that's fine too. Range. Y is greater than or equal to or less than or equal to. Less than or equal to because it opens downwards. The graph is going down. Less than or equal to -3, its maximum value. It has to be smaller than its highest point. And when it says sketch the graph, I'm not looking for anything all that fancy. I'm looking for a graph that has a vertex at -2, -3. -2, -3 is like where-ish on this graph. How do I move? Left 2, down 3. That's -2, -3. And it opens downwards. While I'm at it, I might as well mark where its intercept is. Hey, it hit at 0, -7. Ta-da, there's my graph. The characteristics for vertex form are not individually hard to find. We're going to do one more like this, and then I've got to show you one other thing that's coming up today. F of x is equal to 2x squared plus 4. Vertex is at HK. H is inside the parentheses. Where are the parentheses? Holding on to the x, not the squared, not the 2, just the x. What number got added or subtracted if there's not a plus or a minus there? 0. If you're not adding or subtracting anything, you're adding or subtracting 0. It's at HK. What is K? 4. Axis of symmetry. 0, but specifically it's a vertical line, which means it's an equation, and vertical lines are always what equals 0? X. In this case, equals 0. Y-intercept. Y-intercepts always have what true about them? X has to be 0. If only I knew a coordinate point where this graph had 0 in its x value. I already have an option where 0 is 0, 4. Technically, you would plug in 0. Guess what? 0 squared is 0. 0 times 2 is 0. 0 plus 4 is 4. Open up or open down? Does it have a minimum or a maximum, therefore? If it opens up, it's got a low point. Now, you don't have to write this, but where would that minimum be in this one? 4, the y value of the vertex. Domain. All real numbers. Always all real numbers. Range. Y is opening up is greater than or equal to 4. because of that being the minimum, because of that being the y value of the vertex. I wouldn't be looking for anything special on this graph. It has to hit the point 0, 4. It has to open downwards. Technically, I know this graph is skinny. The other thing you're going to see today, the other set of instructions, are going to ask you to write an equation for the parabola with the following information. And you're going to see instructions like this over the next few days. Yes, ma'am?
You said open up and then you made it.
Oh, I said open up and then I drew it down, didn't I?
My brain got confused. I was like,
Clearly my brain got confused there. I'm just doing it too fast. My bad. Thank you for calling me out. You saw nothing. It was never there. There's not obvious signs that whiteout was used at all. I know. I'm having issues. Okay. Now the information that they are going to tell you today is going to be different than the information they're going to tell you tomorrow. Today they're going to tell you the vertex. And they're going to tell you a point it passes through. Okay. We're going to eventually be learning different forms of quadratic equations, and by eventually I mean tomorrow. And which form you write it in depends upon which information they give you. In this case, I'm giving you a vertex, which means I expect you're going to probably write it in vertex form, because it's the easiest way to go. Vertex form y equals ax minus h squared plus k. Now when you write an equation, which two things stay variables? X and y, or f of x if you prefer to write f of x. But either way, that's staying a letter, that's staying a letter. I need an a, an h, and a k. If I give you the vertex, which two did I just give you? H and k. I'm subtracting 2 inside the parentheses. I'm adding 7 outside. Now x and y should stay x and y, but there's a problem. I don't know what a is. If I don't know what a is, have I fully written an equation? No. We have to find a using this information. This is an x and a y. And if this is an x and a y, I can plug them in here to solve for a. 19 equals a, 5 minus 2 squared plus 7. Giving me a point that it passes through gives me enough information to solve for a. If I want to solve for a, what must I do first here? The parentheses, 5 minus 2 is 3 squared. What's 3 squared? 9. And a times 9 is just 9a. And now it's a nice, easy linear equation to solve once I've simplified a little bit. 12 equals 9a. Divide by 9. Does 12 divide nicely by 9? No. Can I write it as a fraction? Because it doesn't divide nicely. If it came out as a nice decimal, you would. This one doesn't come out as a great decimal. 12 divided by 9. Both 12 and 9 divide by what number? 3. 12 divided by 3 is 4. 9 divided by 3 is 3. It's 4/3. It asks you to write equation, not to just solve for a, which means our final step is to plug a back in. Keeping in mind that x and y technically should go back to being x and y. I'm going to stop right there. Solving is always going to essentially follow the same process. Plug the vertex into your y equals a x minus h quantity squared plus k formula, then plug in your x and y to solve for a. Rewrite your equation at the end.